I'm Stan Moote, CTO with IABM, and I love talking about reference monitors and color volumes and stuff like that. And it's great. I've got Bram on here today. Bram, just tell us a little bit what you guys are doing with quantum dots and QLEDs.
Yeah, so we've really, in the last couple of years, introduced an entire new lineup of HDR reference displays. And we built that really primarily around Quantum Dot OLED technology, which we're very excited about. It has all of the kind of benefits and the things that people have come to love about OLEDs, the very high contrast ratios, very deep black levels, very good uniformity. But it expands upon what the previous OLED technologies could do by being brighter, by, as you were mentioning, having a proper color volume, so there's no color volume collapse on those displays. And then also, I think very importantly, really exceptional off-axis viewing, because it doesn't do you much good to have a display that's highly, highly accurate if anybody who stands even 10, 15 degrees off axis is looking at something where there's a color shift or a contrast shift. And QD OLEDs measurably have the best off-axis viewing of any display technology that's ever existed. And that's really been kind of an interesting paradigm shift in our industry because it allows rooms to be built differently, allows broadcast facilities to be built differently, where you now no longer have to worry so much about being, directly in front of a display. You can really be off-axis. Clients in the post-production suite can be off-axis. In a broadcast control room, people can really be sitting anywhere and still make color critical decisions on the displays they're seeing because of this phenomenal off-axis performance.
Yeah, that's really interesting. I hadn't really thought about that, the building of the rooms, but that really does narrow down the focus there because rooms do
Yeah.
get pretty wide and you can see them there.
Yeah.
So let's get into the your XMP series and just tell me
Sure.
about the color management on that.
Yeah, so that's kind of the panels are fantastic. Obviously, QD OLED technology is I think one of the best technologies in any displays, whether that's for TVs, for computer monitors, for professional reference monitors. I think the thing that we bring to the table with our color management system is highly accurate calibration that is also extremely easy for anybody to use. As a professional reference monitor manufacturer, we've been at this for 21 years now. One of the most depressing things that can happen is that you send a display out into the world and then 5 years later you're talking to a client, you're like, oh yeah, when's the last time you've had that calibrated? And they said, calibrated? I've never had it calibrated. And the thing is, displays drift over time, right? So reference displays have to be maintained, they have to be calibrated. And that in the past has been kind of a daunting challenge. You needed to use calibration software. You needed to understand how to use that. It was very easy to make a mistake and go down the wrong path. So people were hiring external calibrators to do this work oftentimes, which can be quite pricey. Or as in the example I just listed, they just don't calibrate often enough. So what we've done is we built something called Gaia Color AutoCal, and that's built into all of our displays now, both our DM series, which are just our HD monitors, and this XMP series, which are our HDR reference displays. And what this does that is very unique is you plug a probe directly into the monitor, and it basically takes a snapshot of the uncalibrated native state of the display, and it saves that to non-volatile memory. So we actually take over 1,000 readings of the display's native color volume, and we save that to the display. And then when you make any color management selection, so that can be a combination of different EOTFs, different color temperatures, different color gamuts, different signal ranges, different luminance settings, it instantaneously takes that native data and it builds 3D and 1D lookup tables on the spot to take you immediately to that new target. It's basically what a lot of the standalone calibration software does. It's the same concept. You capture the native behavior of the display as much as possible, and then you use lookup tables to take you to your display color space target. What we've done is we've eliminated the need for that standalone computer, and we do all this on board. What's exciting about that is you run one master calibration, and then you can go to thousands of different targets of different combinations of gamut, EOTF, signal ranges, luminance. And it really is very powerful. And it means there's never any surprises, right? So you can have your facility set up to be doing Rec 709, Gamma 2.4 monitoring. Someone comes in and goes, hey, we need to do an HLG project, or we need to monitor PQ. You're not breaking out calibration software, having to redo everything. You just change the modes on the monitor, you get there, and it's extremely accurate. And again, very, very simple. Anyone can do it. You don't have to be an engineer to run this. And it's really allowing people to calibrate the displays a lot more often. And we think that's critical. If we want to have good images throughout the entire pipeline, people have to calibrate and have to calibrate often, and we have to make it easier for people. And that's what we spent over 2 years developing, and that's what you'll find on all of our XMP series.
So what do you figure your average time to cal should be?
So you mean how often or how long it takes?
How often? How often?
So it really depends on usage, right? So the thing with an emissive display is that if you run SDR on it and that's it, chances are you can get away with every 12 to 18 months and you don't have to do it much more often than that. But if you're constantly working on very high APL HDR, you're driving those OLED materials harder, and that causes decay faster over time. So maybe every 6 months or so. That being said, we've made the calibration so darn easy that what a lot of our users do is they go, you know what? I'm starting a new project. Before I start a new project, I'm just going to do a fresh calibration, and it just gives you peace of mind. Because ultimately, any professional reference monitor manufacturer, including FSI, is really selling people is confidence. You have to be confident that the image is correct. And so, that confidence factor of being able to just plug in a probe, you run a calibration, It does everything for you. It warms up the display. It does all of this.
I think that's really cool. That's impressive. So
great.
What other features are you running in the monitor?
So the other big things that we've introduced recently are the ability, kind of related to color management, is now you can set every input up to have its own independent color space targets. So you can have SDR or SDI1 can be an SDR setup, SDI2 can be an HDR setup. Now that's, kind of convenient on its own, but the thing that we've done is we've combined this with our quad view modes. This means you can run up to 4 signals into the monitor on the display at the same time. And each quadrant can actually have a different color space selection. So you can monitor HDR and SDR if you want, side by side on the same display. And that's something you can really only do effectively with emissive technologies like OLEDs or Quantum Dot OLEDs. If you try to do this on an LCD or with a full array local dimming backlight or anything like this, you tend to get problems there because your backlight has to run very high for HDR, but not for SDR. And you can't really do those both at the same time. Whereas on an emissive display, because you're just emitting light at the pixel level, you can do HDR and SDR side by side without a problem. It's a really unique feature, and that's one of the most kind of powerful new things that we've introduced on the displays as of late.
Yeah, no, that's really impressive, because doing that comparison side by side, totally amazing as far as that goes. So your latest product offering is the 551?
Yeah, correct. So the XMP 551 is the latest in our Quantum Dot OLED HDR reference monitors, and it points to something else that I really love about Quantum Dot OLED technology is that it keeps evolving at a relatively rapid pace. So our first display was a 55-inch that topped out at 2,000 nits. Just a couple years later, we have this new 551 out, which is an evolution of that product. It actually goes to 4,000 nits peak luminance. That's a really critical little benchmark, especially when it comes to professional post-production applications, because typically the 2 trim levels that are actually used for PQ, Dolby Vision HDR10 type content is either 1,000 nits or 4,000 nits. So having a 2,000 nit display didn't do us a ton of good compared to having a 1,000 nit display, but a 4,000 nit display really provides the ability to master at this higher level that some facilities want deliverables, brought to them at. So, that's the latest and greatest in our lineup is this new 4,000 nit. It's one of the brightest displays you can buy.
Well, since I got you on here, I want to understand what you think the future is when it comes to display technology, because we've really seen changes over the years. So what's your opinion on this?
Yeah, absolutely. So I think the display industry goes through kind of these fits and starts. There's new exciting technologies, and then they tend to go away. There's some critical things that I think are going to happen in the future. The first is that Quantum Dot OLED has a lot of staying power, unlike a lot of previous niche technologies like RGB OLEDs or like light modulating cell layer LCDs. Because there's a huge consumer application for these displays as well, they're not terribly expensive. So you see TVs, computer monitors, gaming monitors, all being made with Quantum Dot OLED. So the ubiquity of this is going to give it a lot more staying power than I think a lot of other technologies, which I think is a good thing for us in the professional industry. But then additionally, there's new technologies on the horizon like electroluminescent quantum dots. So those are quantum dots that are not actually excited by light, but instead by electrons, essentially. So you just remove the OLED layer altogether. Now, this is probably still 4 or 5 years out before it's a commercial reality. But what's great about this is that because it's quantum dot based as well, it will provide a really smooth transition. So as we go from quantum dot OLED to ELQD, you're going to have very similar spectral power distributions, very similar off-axis type behavior, because ultimately you're still using quantum dots to emit that light. And so I think that that's probably the holy grail of display technologies, because it's going to be even more stable over time. It's going to be able to be driven even brighter. And again, there's this beautiful kind of smooth path from current quantum dot OLEDs to this new ELQD technology. So that's one thing I think we'll see. And then the other thing will probably be, emissive, micro LED type displays, probably for larger format stuff, not so much in the displays that, we're talking about as reference monitors, but certainly, 100-inch plus displays, theaters. I think we may see more of this direct view micro LED technology, which is, kind of similar in terms of the way it looks and operates to things like ELQD. So I think that's kind of the direction that the display industry will go over the next, 5 to 10 years or so.
Well, that gives us a great snapshot where you're heading on that. And it's been really great chatting with you today, Bram.
Thank you so much. I really appreciate it.